Okay, so quiz 2, the data is going to look similar to this. So you'll have an empty Excel spreadsheet, except for the first page with data. Okay. So you'll on the quiz, you'll have the sheet will look basically like this. You'll have one tab with data, with the ID. You'll have 3 predictors and 1 outcome variable. The outcome will be continuous. 1 of the predictors will be continuous, and 2 of the predictors will be categorical. Okay. And that should be obvious when you look at them, right? Because the categorical variables will be coded 0 and 1. Continuous variables will have numbers. In addition to this, I will also give you a write-up telling you like what each of the variables, what's the setup, right? So in this case, I'm not saying that because you already know like the dollars is the sneeches, right? And then they have stars and they have, we've already gone through the setup. But in the new data, I'll give you a setup so that there'll probably be like a second, like another tab kind of in front of this that tells you like what's the setup. So you'll know what the story is. Okay, and then survey, univariate, bivariate, and conclusion. So for the survey, you'll have this. You'll have each of the 4 variables. This I will give you. And then it'll say Q&A, right? So the question, you need to write the questions in a way that give me the variable, right? Either as categorical or continuous. So for example, dollar is giving me like some dollar amount. So I need to ask, you can ask something like, and I would tell you in the setup, is this like monthly income? Is this weekly income? Is this the annual salary? Whatever the unit is, I'll tell you in the setup, right? So let's say this is a monthly salary. Then you could ask, what is your monthly salary in dollars? And then for answer here, what I'm thinking of is like when you do a survey online, a lot of times you can validate the responses, right? So you don't allow users to put in like illogical answers, right? So this will be any number like larger than 0. Right. So, and then or it could be an integer larger than 0 or a number larger than 0. Okay, or sorry, greater than or equal to 0. So I'm not going to be too picky about this, but I just kind of want to know that you know that this is a categorical variable or a continuous variable, right? Okay, and then star is a categorical variable, so you need to ask the question in a way that generates a categorical response. So right, so you can ask like, do you have a star on your belly? Like a yes or no question, right? And then yes is coded as 1, no is coded as 0, something like this. And then for tall, so this is the tricky one, right? Because normally tall is measured continuously, but we're measuring it categorically. So in this case, like you can just ask like, are you tall or not, right? Probably a better way to do that would be like in the survey, you ask like, what is your height in centimeters? And then the researcher, can take that data and code it. And then I can decide the threshold, like if you're above 100 and whatever centimeters, you're tall, if not, you're right. But here, the way it's set up, it's categorical. So you should ask the categorical question, a yes or no question. Are you tall? yes equals 1, no equals 0. Okay, and then age, continuous variable. So this one you ask in a way that generates a continuous response. Yeah. And then that will be the same as the dollars, integer greater than 0. Okay, so that's what I want you to do with the survey question. Oh, integer, just like 1, 2, 3, 4, 5. It's a number, non-decimal number. Yeah. You could just write like, you could just write like that, or x or whatever. However you want to do it, it's fine. Okay. Okay. So univariate analysis, there are two things we need to do. We need to do a table of summary statistics, and we need to do one graph of the distribution of each of those variables, right? So, so a table of summary statistics, right? And this is coming straight out of here. Coming straight out of the lecture slides. Right, where we talked about univariate, multivariate graphs and regression. Here, so univariate statistics and graphs, we've got number 1, table of summary statistics, right? It looks like this. And number 2, graph the distribution for each variable. If it's continuous, you do a histogram. If it's categorical, you do a frequency plot, right? So first of all, let's do the table of summary statistics. So table of summary statistics. I prefer that you order the variables from your outcome to your primary predictor to your covariates, but I'll accept however you do it. So the outcome is dollars, the primary predictor is star, and then the other covariates were age and tall. Right. Sorry. And then for the summary statistics, I want you to count average and minimum and maximum. You don't need to do standard deviation. Okay. So you can just do count, average, min, and max. I'm writing them like this, count, average, min, and max, because that's also the function name in Excel, right? So then for dollars, you can do count, and then you go choose the dollars column. Right. So just for my own reference, the dollars column, because I'm going to reference these columns, dollars is E, star is D.
Sorry. Will you hold this document?
It's already there.
Like with all information?
So it's the second one. Sneech is complete. It's already done. Everything I'm doing now, it's already up there.
Because it's hard to do simultaneously.
Sure. So star is column D, age is column C, tall is column B. So I'm just putting those in there for my reference, right? Because now I'm gonna drag these down. So star is, instead of EE, it's DD. Right? Age is, instead of E, it's CC. And tall is BB. So this is what can you tell from this? It means there's no missing data, right? Now I have another version of this where some of them are not 100, right? So don't assume that it's going to be 100. Right? Some of them might be 99 or 98, right? You could have, there could be missing values, right? And so that's how you can tell when you do the count for each of them. Okay, and then the average is average. So I think I'm just gonna take these and I'm gonna drag them across. Right? Oops, no. I'm gonna take. I don't want to do that. That's what I would normally do, but okay. I'll just do it by hand. Average, same thing, it's EE. Right, so for the first one, I'm gonna go to the data tab and choose it because it gives me this, the data exclamation point. Make sure that I'm going to the data sheet, not in the same sheet. And then the EE is this column, right? But once I have this one, I'm just gonna drag it down and then just change these. BB, now CC. Oops, sorry. And BB. So I'm gonna do it again for min. EE. Drag it down. There are shortcuts in Excel when you kind of learn Excel better, like you can use $ and things to speed this process up, but oops, sorry, I put DG, CC. But I think so BB, CC, DD, EE, EE, DD, CC, DD. Okay, last one. Max. Data exclamation point, EE. Right. I'm just going to drag those down. DD. CC. BB. Okay, once you've done it, take a second to admire your work. No, take a second to check to see if these things actually make sense, right? So what can you check? First of all, if some of these aren't 100, go back in the data and just kind of like scroll down it real fast and say, okay, there's a missing value, that's why, okay? For the categorical variables star and tall, the minimum and maximum should be 0 and 1. If you get anything else than 0 and 1, something's wrong. Okay? So either it was miscoded in the data, so you go like, oh, there's a 0.9 in there. What's the 0.9? Like these are categorical, it should only be 0 or 1, right? Or maybe your function is wrong, right? So double check that for your categorical variables, the min and the max should be 0 and 1. And then if that's right, then we know that this average, so what does this 0.4 say? What does that 0.4 mean? 40% have stars, right? So it's the 40% has whatever's coded as 1, right? Which means star. What's this sub 0.25? Are tall, right? Average age 38, that seems plausible. Like minimum and maximum age, that seems plausible. Dollars 31 to 152, sure, whatever. We didn't know really what that was anyway. Okay, so just double check it to make sure that you don't have anything that stands out as like being really weird. Okay. Okay, so that's the table of summary statistics. What else? What's next? Then you have the distribution for each variable. So for the continuous variables, it's a histogram. That's the easy part. So what are our two continuous variables? Dollars and age. So to do the histograms, you go to data, you choose the column you want, you go to insert, and which of these do you choose? Which one? Which is histogram? Is it 1, 2, 3, 4, 5, 6?
1.
So 1 is the bar plot. 1, 2, 3, 4, 5, 6. 6 is the scatter plot. 4 is the histogram. Okay. So when you're doing the histogram, just one variable for the continuous variable, it's a histogram. So you choose the column of the continuous variable, just like this, right? It's selected. You go to insert, and you choose. Where's my bar go? Okay, insert, and then not the bar plot, not the scatter plot, but the histogram. Histogram. This one. Dollars. Okay. And then my other continuous variable. See, select the column, the whole column. You go to insert, select histogram. Now these are not where I want them. I want these in the Univariate tab, right? So I'm going to select both of these, cut, and paste here, so that they're both in the Univariate tab. So I've got the histogram of dollars, I've got the histogram of age. Most importantly, dollars looks normally distributed. But anyways, those are the two histograms. Okay, now, so I did my histograms for the continuous variables. Now I've got to do the frequency plots for my categorical variables, star and tall. Okay, these ones are a little bit trickier, right? Not trickier, just a little bit more work, because you can't just choose the column, right? So for star and tall, I want to do frequency of star first. So I'm going to make, in my mind, I'm thinking about these 6 cells, right? And here, I'm going to put the 2 levels of the star variable, right? What are the 2 levels? Star and no star. I'm going to put no star and star, because when I make a plot using those 6 cells, it'll automatically assign labels to the x-axis in the order that they're listed. And I want my categories on the x-axis to be no star star, because then I can see if it's a positive trend or not, right? Like if the trend, if it's like star no star, then like logically it's kind of, right? So I like to see the 0 and then the 1 category. So that's why I put no star and star. And now here for the frequency, I say frequency, but it's also just count, right? Frequency plot, so the count. So we're going to use what's the function here? We're counting, but it's conditional. Huh? Average is in the bivariate. I'm not averaging anything here. All I'm doing is counting all of the, in the star column, I'm counting, count if. So for univariate, I'm not averaging anything. I'm just counting in the star column with how many of them are zeros, how many of them are ones, right? So this is univariate, 1 variable. So I'm counting if, count if, and I have 2 parameters. The range is the star column. And what's the second parameter is criteria. So let's go back. What am I? Right, so the criteria here is if no star, 0, right? So my range is the star column, right? Star is D, and then the criteria is 0. So that gives me 60. Now I can drag this down. And here, all I have to do is change the criteria to 1. So you don't have to write it all over again. Right? Where on the table of summary statistics could you double check to make sure that these numbers are right? So table of summary statistics. Yeah, right. So that's a way to double check, right? That 0.4, 40%, this is out of 100. So this should be, that should be 40. Right? Okay. So now I'm going to do this. So I have these are the frequencies. These are the 2 levels that are going to be in my bar plot. So I'm going to select these 6 cells and I'm going to insert. Now, not going to insert the histogram. I'm going to insert the first one here, the bar plot. Like that. Okay, so I have 60 no stars and 40 stars. I'm going to add in data labels. I'm not going to add in error bars because I'm not doing a t-test or not predicting whether these levels are statistically significant, right? I'll do that in the bivariate. Right here, they're just the counts. There's nothing statistically significant or not significant about them. Well, you could do a t-test to see if these are yeah. Anyways, you don't need I think just the data labels are fine. Okay, now I'm going to copy it. I want to do this again for tall, so I'm just going to copy and paste. I'm just going to change the title. Now notice, like if you do it this way, if you format it this way, when you insert it, it sets the labels on the x-axis and the title of the graph exactly what you want it to be, right? You don't have to like retype them. So frequency of tall, I have no tall, not tall, and tall. Here, the criteria 0 and 1 are the same. Only thing that's changing is the column, right? And tall is B. So I'm just going to change my D's. Just change my D's to B's. And my D's to B's. Okay. And how can I double check if those numbers are correct? Because the average here is 0.25 and 25 out of 100. So double check. Yeah. Okay. I take those 6 cells, insert bar plot. Okay. And I'm going to add data label. Yep. Okay, and you are done with the univariate, right? So we did the table of summary statistics, we did the histogram for the continuous variables, we did the frequency plots for the categorical variables with a little bit of trouble, but we got it done. Okay, bivariate next. So with the bivariate, with bivariate graphs, right, we're looking at whether the outcome variable is continuous or categorical and whether the predictors are continuous or categorical. So for us, the outcome variable is continuous, right? It's dollars. So our predictors, we have 1 continuous predictor and 2 categorical predictors. So we're either going to make a scatter plot or a box plot. So with the bivariate analysis, all I want you to do is make 3 plots. 1 scatter plot for the continuous predictor and 2 box plots for the categorical predictors. And the outcome variable is going to be the same in every case. So I want you to do, what's our continuous variable? So we have 1 outcome, dollars, and we have 3 predictors. So I want you to do 1 bivariate. I want you to do star on dollars. I want you to do age on dollars, and I want you to do tall on dollars. So the bivariates that I want are, I want to see the correlation between the outcome variable and each of the predictors one at a time. So star on dollars is going to be a box plot or a scatter plot. So we do the scatter plot when both variables are continuous. So we do a box plot when the outcome is continuous and the predictor is, and the explanatory variable is categorical. So star on dollars is going to be box plot or scatter plot? Box plot. Age on dollars is going to be scatter plot or it's going to be a scatter plot. Tall on dollars, box plot or scatter plot? Box. So your scatter plot is age on dollars. Your box plot is star on dollars and tall on dollars.
So we have outcome is dollar and we have 3
3 explanatory variables. So for the bivariate, I want each explanatory variable on the outcome, one at a time. So star on dollars, age on dollars, tall on dollars. So the scatter plot's easy. Scatter plot's just as easy as the histogram was. Okay, you can do it automatically. But for the scatter plot, for the scatter plot, it's going to go end up in bivariate, but to do it, you can actually do it in data, just like the histogram. So for scatter plot, you choose, instead of choosing just one column, you push control and choose the second column too. So you choose the two columns, you select the two columns you want in the scatter plot at the same time. And then you go up to insert. Where's my scatter plot? 1, 2, 3, 4, 5, 6. 6. Scatter plot. And there it is. This is dollars. Dollars by what?
Age.
Age. I'm not going to require you to put axis labels because it just normally we would, but it takes more time, right? And I want you to be able to go through this quickly. But what I do want you to do is add in the easy stuff. So click here, just add a trend line. Okay. So you can just click this little chart elements thing and go way down at the bottom and click trend line. And that'll add the trend line. And that's useful when you're trying to look if there's a positive correlation, if there's these two variables are correlated. So that's that. And I want to put it in the bivariate tab or sheet. So I'm going to copy, paste, or sorry, cut and paste. Okay, so that's the first of my 3 bivariates. Okay? So just here, I want income by age. It's a scatter plot. You can maybe make this on your own, right? You're going to have income by star. That's going to be a box plot, and you're going to have income by tall, also a box plot. Your variables are going to be different in your example, right? It's not going to be income, dollars, tall, whatever. It's going to be something else. Oh, sorry, I got income and then dollars. Yeah. Anyways. Okay, let's make the box plots and then get you guys out of here. Box plots, we already made a box plot here in the univariate. These are both box plots, but these box plots are not showing the same, the y-axis is not the same. So in the univariate analysis here, the y-axis is a count of the variable that's on the x-axis. There's only one variable in this graph in the univariate analysis, right? It's tall, and the count, and the y-axis is the count of the two levels in that variable, right? So there's only one variable here. This is a frequency plot. Here, it's not a frequency plot, right? It's a bivariate plot where the y-axis is the average of one variable by the levels of another variable. So we're not counting the levels. Now we're taking one variable on the x-axis, one categorical variable like star, no star and star, and we're taking a second variable, dollars, and we're calculating the average value of dollars for no star and the average value of dollars for star, right? So, but the structure looks the same. So I'm going to copy this and paste it. I think I'll just do both of them. You can copy and paste both of these just to save yourself time. Okay, but the title has to change. So what's the title of this going to be? Yeah, and the summary statistic here is actually going to be average. So you can say average dollars by star. Right? So you had dollars by age. Here you aren't averaging because you're showing like all of the points, right? In these here you're calculating the average dollars for no star and the average dollars for star, and then you're going to compare them. Right? And then here, same thing. It's going to be average dollars by tall. Okay, now these numbers need to change. So we're going to use a different function here. Before we use count if, and you only had to choose one column and then specify if you want to count the zeros or ones, right? Here, here it's complicated because we're still taking the star column. We're still looking at if it's a 0 or 1, but if it's a 0, then what are we doing? We're averaging the values of a different column, right? So we're looking at stars. We're looking at stars. If the stars are 0, then we want to average dollars for those cases where stars are 0, right? And sorry, for here. And then for here, we're looking at star, all the cases where star is 1. What do we do if it's 1? We're not counting the ones. We're going to look over at the dollar column. We're going to average the dollar value when stars are 1. Okay? So that's why this formula doesn't have 2 parameters, it has 3 parameters. So the first parameter, the first 2 parameters are just like count if. You look at stars column, the criteria is either 0 or 1, but now you have to add a 3rd parameter, which is what's the variable that you want to average over. Okay. So instead of the count if function, this is going to be average if. Right. It's still conditional on the 0 or 1, right? So, but it's average if. So here average if. You've got range, criteria, and then the average range, right? So the range here is star. Then the criteria is 0. I want to average over stars where it's 0. And what do I want to average? Dollars. So now you choose the dollars column. Okay. So that's the average dollars when stars, for the stars, when star is 0. Right? And now you only have to write this function once, right? Because now you can copy and paste it. Right? So for here, what do I have to change?
0 to 1.
All you have to do is change the 0 to 1, right? Still looking over stars, and I'm still averaging over dollars, but now I want to average dollars when star is 1. So all I have to do is change the 1. Okay. What about here? What do I have to change now? So this was stars before. Now I want to do the tall, right? Which is tall? Yeah, B. Okay, so these need to go from BD to BB. What else needs to change?
It's tall, it's 1.
So yeah, for here, nothing, right? Because it's still 0 and I'm still averaging over dollars, right? And then here, I'm just gonna copy this. And what do I need to change here? 0 to 1, right? Great. So I've got the 2 tables. Now I can drop in the box plots, right? Same way. This is, you know, one of the reasons I'm having you do this exercise is because a box plot, when you make a frequency table like this, and when you make a bivariate like average over the levels, they look the same, right? The way that you set them up, right? And the way that you make them, it's almost identical, except the data, what those levels of those bars are 2 very different things, right? In the univariate, you're simply counting the numbers of 0s and 1s. In the bivariate, you're actually introducing a second variable, right? And you're calculating the average of the variable for the not tall and average of variable for tall. So, okay, but when you actually make them, it's the same. So you're gonna drag those 6 cells, insert, box, boom. And the nice thing is, when you do it this way, it's perfectly formatted, right? So you don't have to change anything. You can just go in here and add here, we're going to add 2 things now. We're going to add the data labels, and we're going to add error bars based on standard errors. Okay. Why do we do that? Because the question of whether, okay, yes, there's a difference. It's about a 20-point difference, right? 18, 19-point difference. Yes, there's a difference, a big difference, but is it statistically significant or not? How do you tell? If the error bars overlap, it's not a statistically significant difference. If they don't overlap, the difference is significant. Here it's ambiguous. It's hard to tell if you eyeball that. It looks like they're almost like that. So it's hard to tell if they're overlapping or not overlapping. The example like you will not be ambiguous. They will either be clearly overlapping or they will clearly not be overlapping.
But if this is, for example, the 2 outcomes.
Yeah.
How do we? I mean.
Yeah. Then the
Do we say that it is statistically?
so think about the p-value. Let's say these are standard errors with a 95% confidence interval, right? Say these are the 95% confidence intervals and they're almost overlapping. Then that means that the alpha, the p-value, is like 0.05. It's either like 0.049 or 0.051, right? It's like right on the verge of that 0.05, right? Which in my opinion still means like statistically significant, right? So even if this was like, even if they were just barely overlapping because you went over the 0.05 threshold, maybe the p-value is like 0.051, you just over the 0.05 threshold, then the way I would write that up in my write-up is I would say there's weak evidence that these are of this. I would call that weak evidence that these are statistically different. There's a significant difference between them. There's obviously a difference between them, right? The question is like, is it significant or not? And that's based more on sample size, right? So probably if you had a bigger sample size, I only have 100 observations here. Probably if you had 200 observations, you'd get like the same levels, but then those error bars would get smaller. And then it'd obviously be like statistically significant difference. Right? So in that case, usually I just say like, probably statistically, there's probably a significant difference, but we just have weak statistical evidence that there's a significant difference between them. Okay, what about these? Huh? Oh yeah, 14%. It's a race. I'm going to see if it's a race, if I can get you out of here before it's done. So insert bar plot. Okay. And I'm going to add the data labels and the error bars. Okay, this one, statistically significant difference or not? Hard to say. Right on that alpha point equals 0.05 threshold. It's right on that 0.05 threshold. Substantively significant or not? So statistical significance is one thing. If you have an enormous sample size, you will find statistically significant differences for anything that you calculate. But what about substantively? Substantively, is this a significant difference or not? Look at the numbers. This difference is a gap of $20. This is a gap of less than $1. Right? Why is it like that? It's because Excel automatically, in kindly, no thank you, scaled my graph for 90.5, right? If I go back, I'm not going to require that you do this, but if I go back and I change my graph. No, I don't want to. Okay. I thought it was a format chart area. Sorry. Oh, I forget how to do it. There's a way. That's not it. Anyways, if you format your format axis, is that right? Yeah, okay. Here are the axis options. The minimum here is 90.5, right? Let's make the minimum like the absolute minimum of 0. Yeah, right. This is another way where you can cheat with statistics, right? Visually, like, right? So if you scale it to 0, whether those are statistically significant or not, like inscrutable, I can't tell, those are both like the length of, those are both the width of a hair. Right, but substantively, even if they were statistically, even if the difference between them was statistically significant, the substantive difference is nothing, right? Okay, so that's the bivariates. You've done the scatter plot for the two continuous. You've done two box plots for the continuous outcome with categorical predictors, right? Last and important thing is in the conclusion. I want you to write 3 statements. Right? I want you to evaluate these in terms of their correlation, right? Is the predictor correlated with the outcome variable? So for the scatter plot, correlated or not correlated? It's correlated, right? What would it look like if it wasn't? What would a not correlated scatter plot look like? It look flat. Because that would mean that regardless of what age is, the level of the average income is the same, right? But the fact that there's a trend line, positive, suggests that there's a positive correlation between age and dollars, right? Which means that the older you get on average, the older you get, the more money you make, right? So there is a positive correlation between age and income. That's one thing, so you're gonna say that. Dollars by star, positive correlation, negative correlation, no effect. The statistical significance is a little bit ambiguous, but in terms of effect sizes, it's significant. It's like $20 difference. It's like a 20% difference, right? Not insignificant. So I would say here too, there's and again, like the example that I give you will not be ambiguous, right? It'll either be like flat, with no correlation, or it will be like clearly like a positive or a negative correlation. Right? So this one's, star is taller than no star. Star predicts higher level of income. So I would say yes, star is correlated with income, is positively correlated with income, meaning if you have a star, you're going to earn more money. Okay, tall? No, not at all. Right. So, so what I will give you in the conclusion will say basically. I'll do this for you. Oops. Yeah. Yep. So I'll say in according to our bivariate analyses, it appears that. And then I'll have these 3 here, right? And it'll look like this. And then you can make these statements, right? So number 1, and I want you to like write it out in English, right? Write out the sentence. According to our bivariate analysis, it appears that age is positively correlated with income for dollars. Star is also positively correlated with dollars, and tall is not correlated with dollars. You only have 3 options, right? Positively correlated, negatively correlated, or not correlated, right? So that's all you have to write. And then I'll have something like cheeky down here saying, in order to test something like to the effect of, we would need to do multiple regression, right? Linear regression to estimate. I don't know. You don't have to write that. I'll have something cheeky down there I'm just trying to like, emphasize the point that like we've done these univariate statistics, we've done the bivariate graphs, and if we're going to go all the way, we would do regression, right? But for the sake of like, not forcing you to do that, we'll stop short of that. Okay. Okay. Any questions about this? So you will do this with a partner if you like, or by yourself. I'll have a sign-up sheet like side by side, and you'll write your name and your partner's name. At the end of the test, just like last time, as long as one of the two of you uploads the file, like I'll grade, I'll give you both the same grade. Yep, I know, I haven't even decided what I want to do for part 2. Maybe I won't have a part 2. Maybe we'll just have a part 1 and a part 3. Is
Yes, that's.
that okay? Unless you really, it seems like you really want a part 2. I'll think of something very devious and identical. All right, I'm gonna upload this. This is the recording right now on Moodle, or sorry, on Zoom. I'll upload this recording somewhere, and I'll upload the link to Telegram. So if you want to open up these files, Excel files in Moodle, you can open up the empty one and try it yourself, right? As much as you want. You can practice like as many times as you want over the weekend. Fun, exciting. All right. All right. See ya.